Okay, now let's take a look at relationships. And this is one of the areas where Fluent API is superior to data annotations because we don't have that much control over relationships using data annotations. Okay, first let me show you how to configure relationships with Fluent API, and then I will walk you through various examples of relationships like one-to-one, one-to-many, and so on. So here is the basic idea about configuring relationships. Imagine we have a relationship between type 1 and type 2. When it comes to configuring relationships with Entity Framework, we can start from either end. It doesn't matter. So in this example, I'm starting from type 1 going towards type 2. First, we need a reference to type 1. So we use the entity method. And then depending on the type of relationship, we call one of the methods that you see on the right side. We call hasMany if type 1 has many objects of type 2. We call hasRequired if type 1 has only one object of type 2. And we call hasOptional if type 1 has 0 or 1 object of type 2. Okay, so this is how we configure a relationship from one end to another. Now we need to configure the reverse direction. So from type 2 to type 1. And again, based on the multiplicity of the other end of the relationship, we call one of the methods on the right side, with many, with required, or with optional. So to recap, we start with one of the methods on the left, and then we configure the reverse direction with one of the methods on the right side. Now let's take a look at some examples. So here is an example of a one-to-many relationship. An author can have many courses, but each course has only one author. Again, this is something that I'm assuming here. In a real-world scenario, a course can have multiple authors, but we'll get to many-to-many relationships later in this lecture. So let's imagine we want to configure this relationship from left to right. So we start with modelbuilder.entity to get a reference to the author type. Now, because an author has many courses, we call hasMany method. Note that this method takes a lambda expression. So here A is short for author, and we are specifying that the courses property in the author class is a navigation property to the end of the relationship. Okay, so this is the configuration from one side to another. Now we need the reverse direction. So we start from course going towards author. A course has only one author, so we call with required method. And again, we supply a lambda expression that specifies the target property. So C.author represents the author property in the course class that is a navigation property to the end of the relationship. Now we can optionally specify the name of the foreign key. So in the course table, we're going to have a column that references an author. And by default, as I told you before, that column is going to be called author_ID. So if you want to override that and use author ID, we use hasForeignKey method. Again, this method takes a lambda expression that references the target foreign key property. Now the interesting thing here is because we're using lambda expressions, if I rename this author ID property or author property in the course class, these references will be automatically updated. In the last lecture, I told you that the foreign key attribute is fragile because it uses a magic string. So if you rename a property, that magic string is not going to get updated. And you're going to get runtime exceptions. All right, now let's take a look at an example of a many-to-many relationship. So here we have a course and a tag, and there is a many-to-many relationship between these two types. Again, we start from one side and configure the relationship. We start from course going towards tag, but again, the direction doesn't matter. You can start from any end. So starting from course, first we need a reference to the course entity. So we use modelbuilder.entity of course, and then we call hasMany method because a course can have multiple tags. And the lambda expression you see here specifies the name of the navigation property in the course class. So in the course class, we have a property called tags that gives us access to all tags for a given course. Okay, now we need to configure the other direction. So starting from the tag, going towards the course. So we're going to call with many method. That's it. So that's how we configure a many-to-many relationship between two types. Now the interesting thing here is, even if we don't write this configuration, Entity Framework can infer based on the associations between these two types that this relationship is a many-to-many relationship. So you might ask, then why do we have to write all this code? You would write it only if you want to supply additional configuration for this many-to-many relationship. Remember earlier we had an intermediary table called tag courses, and I told you a better name would be course tags. So to override that, we can call the map method here, and this method takes a lambda expression that takes a mapping object. This mapping object has a method called toTable, which specifies the name of their intermediary table. Again, this is another configuration that you cannot achieve with data annotations. Another example, 1 to 0 or 1. So here we have a course, and a course can optionally have a caption. But each caption belongs to only one course. So let's start the configuration from course to caption. So we call modelbuilder.entity of course. And now because a course can optionally have a caption, we call hasOptional method. And again, similarly, here we supply a lambda expression that specifies the name of the target navigation property. Now the other direction. A caption has one course. So we call withRequired method. So what I want you to take away here is that you start with one of the has methods, like has many, has required, has optional, and then you call one of the with methods, with many, with required, with optional. As simple as that. The only tricky one is one-to-one relationships, but I'm going to make it really easy for you. So here we have a course and a cover. A course has one cover, and a cover belongs to one course. Let's start configuration from left to right. So modelbuilder.entity of course has required cover. Nothing new so far. Okay, now the reverse. But I got a question for you. In this relationship, which type is the parent and which type is the child? Course is the parent and cover is the child. We cannot have a cover without having a course in the first place. In Entity Framework, parent and child are referred to as principal and dependent. So principal means parent, dependent means child. So back to our configuration, we are going from right to left. So the end of this relationship is the principal end. So we're going to call withRequired principal method. And we can supply a lambda expression that specifies the name of the target property. So in this case, C is short for cover. So in the cover class, we have a property called course. What I want to clarify here is when you are in a one-to-one relationship, you can't use has required and with required because Entity Framework doesn't know which one is the parent. And this is crucial because when you're adding records in your tables, Entity Framework should create the parent record first before it can create the child record. That's why in a one-to-one relationship, you need to call withRequired principal or withRequired dependent method, depending on which direction you're going towards. Let's review this example one more time, but this time I'm going to start from the opposite direction. So this time I'm going to start from the cover, going towards the course, and coming back. So modelbuilder.entity of cover has required course. Nothing new so far. Now the reverse direction. Again, just to recap, course is the principal and cover is the dependent. Now we are going from principal towards dependent. So we call withRequired dependent. And we supply a lambda expression to specify the target property. So C here is the course, and the course has a property called cover that gives us access to the related object. Now let's flip over to Visual Studio and see Fluent API in action.